Professor Sills here, and I wanted to address what is probably headed your way. I'm out in Steamboat, Colorado, and we had 3 inches of snow last night that wasn't quite forecast. And you've got quite an event. It looks like we'll be impacting the Northeast in the next few days. So I want to go over that with you. Let's see. My computer, as usual, is acting a little squirrely. We're on a CBS New York page, New York, cbslocal.com, and they indicate here this is Dateline from late last night, 11:20, of course, your time, p.m. Last night, the 24th, you've got a hurricane, and it's appropriate. We just finished the hurricane study. Your exams are done and graded, and you can see the results, and I've made some comments. Overall, the results were okay. I think some of you know you need to study a little harder or really internalize an understanding of what's going on. And this storm, well, let's talk about it, because I think you're going to see how a few things tie together. First of all, this storm, typical of this time of year, originated in the Caribbean. I believe it originally headed a little bit westward. I didn't follow it early on. It made its curve north, and it is expected to curve to the northeast. And again, that's typical. That's the typical eastward and then westward and then eastward movement eventually. And that's because of the Coriolis effect causing that curve to the right. And then eventually the westerlies pick up. The westerlies, just using my cursor here, blow across the United States. You're looking at New Jersey right here. They blow across the United States from west to east and tend to blow everything out to sea. And that's what makes this upcoming event all the more unusual. I want you to see what's going on. So I'm just going to close out this page. This is just a neat headline. You can go to New York.cbslocal.com, New York.cbslocal.com, and you can see that headline if you want to look at it. I'm sure it's going to be updated. 5 inches of rain, 65-mile-an-hour wind gusts. That'll be impressive, and that will take down some trees, and it will cause some flooding locally, and, in general, create a bit of a mess. Now, and I'm also going to show you the most up-to-date information that isn't even in the forecast yet. And I haven't really processed it, so we'll talk about it as I see it. This is from the Washington Post. Again, WashingtonPost.com. You can go directly there. You don't need the link from me. I'm sure they will have links up there. They're indicating mega storm threat growing from mid-Atlantic and northeast early next week from Hurricane Sandy. This is a classic example of a tropical storm that is becoming a hurricane, grows to be a hurricane. And as it grows to be a hurricane and heads northward, it loses its tropical characteristics. What that really means in English is it's losing the eye. Okay, it's losing the eye, and it's beginning to become more of an extratropical storm. What we call extratropical storms are also called mid-latitude storms or winter storms, for that matter. Now, tropical systems feed on warm water, and let me address another exam issue. They feed on warm water, and what that means is that warm water has a propensity to evaporate, all right? That produces a lot of water vapor in the air. That's why it's so humid in Florida much of the year. There's a lot of warm water surrounding Florida, and that water evaporates, and it goes right into the atmosphere. New Jersey becomes humid in July and August, more due to advection than what's going on in the Atlantic adjacent to New Jersey. In other words, advection is the transport of warm, humid air from the Gulf northeastward to New Jersey. Look at a map. There's a straight line between the Florida Panhandle and southern Alabama and southern Mississippi and New Jersey. When you have prevailing winds from the southwest, as you do primarily in June, July, August, and early September, you get a lot of warm, humid air advecting into New Jersey. At this time of year, what's becoming more prevalent is the polar air coming out of Canada, continental polar air from the northwest. That air is, of course, much cooler and drier. It doesn't have the moisture content. Now, what you're looking at here on this series of images from the Washington Post is different computer models. This shows a very, very strong storm system with a lot of isobars, lines of equal pressure surrounding the center of the storm with a very low central pressure. If you turn on almost any weather report, you're going to hear, and the barometric pressure is. Well, normal air pressure at sea level, which is pretty much what most of New Jersey is, I'm up here at about 7,000 feet. Normal sea level pressure is about 30 inches of mercury. And you can read up what a barometer is and how it all works, and you can learn that. It can also be measured in millibars. It's just another measurement system, the same way centimeters are an alternate measurement system to inches. Instead of in inches, 30 inches, in millibars, it's 1013.2 is normal sea level pressure. Above that is what we call high pressure, which is what we normally associate with fair weather, and below that is low pressure, which we normally associate with stormy weather. This low pressure system, well, you can see in this graphic here with a different model, puts the center of a extratropical mid-latitude winter storm with a 946 millibar central pressure over southeastern New England. That's incredible. If that verifies, if that really happens, it's going to be extremely windy, extremely stormy, and because the circulation around these systems can wrap precipitation around and even wrap in cold air behind it, the possibility of snow exists, maybe not in Patterson, but very potentially as close as the higher altitudes of West Milford, where they're up around 1,000 feet. And certainly up into the Catskills and up into the Adirondacks of New York State as you proceed about 90 miles northwest of New Jersey, or more like 200 miles, 250 miles northwest of New Jersey up into the Catskills and the Adirondacks. I'm drinking ginger water, ginger tea, and that seems to help a bit with the cough, although you still see it picking up in my voice. As I say, it helps. Okay, so one of the things I want you to get from this graphic here is that meteorologists use different models to forecast the weather. Let me get rid of this one. This is a ensemble analysis. In other words, this is kind of a consensus where all of the computer models are looked at and meteorologists say, okay, here's what we expect. We expect the storm to travel northward, begin to get caught up in the westerlies and pushed out to sea, and then get pulled back in a very unusual pattern. From here to here, this is a rare event. This doesn't happen often. It rarely occurs. And I'm going to show you why it's going to occur this time. But the fact that it happens indicates that you have a very strong ocean storm, a former hurricane, which has lost its tropical characteristics, which is going to get pulled back into New England, or maybe even a little further south. And as it gets pulled back in, because of a cyclonic circulation, what does that mean? It means it's going to be spinning like this. If the center was, let's say, over the western Mass New York border, this would be the circulation. Now, as I move the arrow, where is the air coming from that is reaching New Jersey in this circulation? If your answer is from the north and northwest, you're right. So that as long as the storm is off to our east, we're on the cold side of the storm. Now, I'm not suggesting New Jersey's going to get a snowstorm. Like I said, the air probably isn't going to get cold enough. And if it does, it won't be in Patterson. It'll be further north and west at higher elevations, higher altitude. But it's going to be a really stormy storm. Now, this next graphic, and again, I'm going to close this one out. This is from the Weather Underground, all right? WUnderground.com, and I've given you that before. If you go to WUnderground.com, I guarantee this is going to be one of the headlines for the next few days. Now let's go to this one that looks like a bunch of spaghetti. And in fact, some people call it a spaghetti plot. Reason being, you are looking at the computer models. There are 10 or 15 of them. And you can see that they're all in pretty close agreement, moving it north-northwestward towards central Florida's coastline, and then north-northeastward along the Carolina coastline, and then they begin to diverge. One takes the storm, all the way out into the central Atlantic. 2 or 3 take it up into the North Atlantic and then curve it back there. But then the majority of them are curving it back even earlier than this white line, which is what the official forecast is. In other words, the National Weather Service, what does a meteorologist do? They look at these various computer models, and then combining it with their own personal experience, they make a judgment call. They write off, let's say, an outlier of a computer model calling for it to move all the way out into the Atlantic, and they discount these, which are bringing it in right over the mid-Atlantic, over central New Jersey, South Jersey, and over Washington, D.C., and they say, we think that the most likely scenario is it will get pulled northwestward into central Maine and northern Vermont, and then you see one more hook there, moving it back towards the east, which is where it will begin to follow more of a normal pattern of west to east movement. Now, let me take a look with you at the latest GFS, which is the best model out there. I don't spend my entire day looking at 50 different models, and it would take too long with my internet connection, so I look at one. I look at the GFS. I'm happy that these kind of spaghetti plots are out there because I can see what the other models are showing. I just don't see them in as much detail. This is the 12Z GFS. Now, again, I'm using this time with you, for those who are with me, to teach some extra things that you're going to pick up on, hopefully, and you're going to use not only in your life here, but maybe in your daily life, because understanding time zones in our global community is critical. All time zones are based around Greenwich, England, which is 0 Greenwich Mean Time, or 0Z. 12Z would be 12 noon. We are, as long as we're on daylight, 4 hours behind. I say we, you in New Jersey, are behind England by 4 hours. England is 4 hours ahead of you on the Greenwich Mean Time. So the 12Z represents 8 a.m. So this is from 12Z or 8 a.m.'s computer model run on the 25th. So if you're seeing it today, I'm going to try and get this thing uploaded pretty quickly. You're seeing fairly current stuff. And you can go to my NCEP model from my previous videos, and I'll give you the link again here. So this is just a 6-hour forecast, valid for 18Z, which would be 2 p.m. in England, or 10 a.m. Which would be 6 p.m. in England, or 2 p.m. in the New York metro area. What I see here is a cold front situated with a low-pressure system, a fairly strong one, over the northern Great Lakes. Cold front running north to south into towards Texas, where cooler weather is prevailing. Out where I am, we have a little bit more moisture moving in, so there's more snow forecast for this area. I'm roughly right about here. And the 540 line, which is what I explained to you as the rain-snow line, it doesn't always hold well in the mountains, but we're north of the 540 anyway, up in Steamboat. We're going to get snow. And that'll be nice. It'll be another sugar coating of snow, and I think by the weekend it'll be in the 50s in the afternoon, so that snow will be long gone. Happy to see it come, happy to see it go at this time of year. Maybe after Thanksgiving, I'll be happy to see it come and show up all the time. Anyway, now let's move this forward. I want you to see a few things here. So we can see the moisture building up over Colorado, where I am. So by 3Z on the 26th, now let's think that through. Subtract 4 hours. It's 3 a.m. in England, it's 11 p.m. in New York, and it's 9 p.m. where I am. So by 9 o'clock my time, I'm looking at more snow falling overnight here. Maybe I'll get a chance to do a little cross-country skiing in the morning tomorrow. Who knows? This morning's problem was the ground is too warm. It was 70 degrees here a couple days ago. So the grass is covering the snow beautifully, but the paved roads are all melted. I mean, there's absolutely no travel trouble. Very similar to New Jersey when you get your first snowfall in November or early December. Now, we move forward. Now let's start focusing on New Jersey. We see an approaching cold front here. This is associated with what we call a trough. Let me show you what that trough looks like. This is 30 hours into the future. We're now looking at Friday at 18Z, which would be Friday afternoon for you. And this is now shifting gears to a 500 millibar chart. We're no longer looking at what's happening at the surface. We're looking up at 18,000 feet. Why does 18,000 feet matter? It's the steering currents. So as we look at this over a few hour period, this is validated from early this morning, same time period, 0 hour would be 12Z this morning, or 8 a.m. on the 25th. And you can always rewind this and watch this a couple of times, because I know it gets confusing, but I'm not going to repeat myself, and I'm not going to trip over myself. So if you watch this a couple of times, you'll see what's going on. I want to introduce you to a trough. This is a trough. It usually, at the headline, remember I said there was a cold front in the Midwest, north-south orientation towards Texas. It is in the leading edge of the trough where you see the shift between warmer air to the east and cooler air to the west. You are under the effect of a ridge. This is a ridge. This is a trough. And this is a ridge. This is an upper air cyclone. So from the upper air cyclone, you have, or an upper air low, you have a trough, and at the heart of the ridge, somewhere down here, there might be a high, all right, or an anticyclone. So you're under fairly tranquil, fairly mild weather, but look at how progressive this pattern is, and look at how it begins to change. So I'm going to progress this to 30 hours. Now, 30 hours, you have on the surface, the cold front is running north-south through northwestern Ohio, and the trough is very steep. There's a very sharp line. You're still under the ridge, but the ridge is departing eastward, and the trough is progressing eastward. You may have heard on the media that they think this storm is going to get pulled into the trough. I don't know how much of a pull it is so much as it just gets absorbed into it or circulating around it. You're going to see what's going to happen to this trough in a minute. It's already a closed-off trough, or closed trough, or closed low. And it's got two iso lines. These are lines actually of equal height. Don't even go there. It's got two iso lines closed around it, whereas these are open lines. You know, they're just not closing around anything in particular. There's a little closure right there. You're going to watch what happens to this closure over time. Now let me stay with the upper air analysis, again, around 18,000 feet. And let's move this forward from 30 hours, which is Friday afternoon. Let's go straight to over 100 hours, which will take us through the weekend. Watch what happens. Now, we're up around 63 hours. You don't see much of an influence from the south, but you do see this trough really pulling warm air straight from the center of the country northward, virtually up to the North Pole. So in this area here, on the eastern edge of the trough, there's very mild air working its way very, very far north. And you'll see that reflected in the thicknesses on the other chart. Now we see a little bit of a cyclone here. That is the reflection of the hurricane at 18,000 feet. We're up at 81 hours. It looks like we're on Sunday afternoon. All right, Sunday the 28th at 21Z. Now, do you see this trough taking on kind of a backwards tilt? It's now tilted lower right to upper left. In other words, southeast to northwest. This is what we call a reverse tilt. Anything that's out here is going to get pulled in that direction because that's the prevailing wind. The wind will be from the ocean at 18,000 feet up inland. So a storm system which is being steered by your 18,000 foot winds is going to get steered towards the coastline. That's very, very unusual. Why? Because reverse tilting is very unusual. This is far more common. This is a very gradual ridge with movement in general from west to east, southwest to northeast, northwest to southeast. Things become violent when you get close to this trough and on the eastern side of the trough. And look who's on the eastern side of the trough, New Jersey. I'm continuing my upper air analysis. Do you see how this is getting drawn into the circulation? Now we're at 111 hours. We're Tuesday at 3Z, which means this is late Monday night. Look at that. It's getting pulled right in, and you have a closed system, a closed low, essentially, at 18,000 feet being dragged right towards the New Jersey or southern New England coast. And again, this is now Tuesday morning. Look at that. So I'm circulating forward. I'm now up to Tuesday late afternoon, and you still have a very, very strong closed circulation just east of New Jersey at 18,000 feet. Folks, this is very, very dynamic. There was a movie made a few years ago called The Perfect Storm where something like this happened, but it didn't happen until really off the coast of Nova Scotia, out here. This one seems to be setting up shop right over or just east of New Jersey. If this verifies, you're in for a hellacious storm. Well, notice it begins to pull in over New Jersey. This is now late Tuesday night, 3Z Wednesday. And this might be the strongest panel here. 522 is the central circulation. It's a height, but it's an indication of how deep the low is. And it's right over New York City. And this would be at 1 a.m., 2 a.m. On Wednesday morning. Now, as we go further into the future, you see how it's beginning to weaken. It's kind of unwinding. It's weakening itself. And you begin to see a ridge develop out here in the west. This is by November 1. By November 1, where I am, snow's not going to be on the ground and snow's not going to be in the forecast. We're just going to be in some very mild weather. And again, I don't care. It's early November. If this happens in the middle of December, I'm going to be upset. But early November, that's great. I'm looking forward to another shot of Indian summer. Again, we go further into the future. Notice how the 534 height is disappearing. The 540 disappeared. And now way into the future. And by the 6th of November, it's beginning to look like a much more tranquil atmosphere. But that's all the way following another week. So yeah, this is you actually have some ridging occurring by the 8th of November. Now, let's get back to the surface game and see what happens. So here we are. This is the 26th. This is now representing Friday at 2 o'clock in the afternoon. I'm working in your time zone, 18Z, subtract 4 hours, 1,400 hours. That's 2 p.m. I'm recording this at about noon, so a couple of you might even see this before it is 2 p.m. You've got this cold front to your west. You've got any of the colder thicknesses are way to the west. The 540 is down in the Oklahoma Panhandle, but there's no moisture, so there's no snow falling. East of that cold front, you've got warm air working its way all the way up. The 540 line is somewhere over near Hudson's Bay or over Hudson's Bay. So it's way, way north. And as I said, that's drawing warm air all the way up east along the Appalachians and the East Coast all the way north. So if Killington, Vermont is thinking of having an early open to the ski season, ain't going to happen. At least not on this pattern. Let's watch what happens. So we're going to go a little further forward in time. And you start seeing this come in on the south end of your map, which is the hurricane, Sandy. You see the tight isobars, lines of equal pressure. They are wrapped around very tightly, which is why there will be high winds along the coast. And you see the blues and the purples indicating copious amounts of rainfall along the Carolina coast, even with the storm not even centered on this map yet, but well off the coast. Now, and this is valid Sunday, early Sunday morning. So now let's take it further north and notice it's moving north-northeastward exactly as I showed you in the models it was forecast to do. Now we're at Monday at 9Z. Again, subtract 4. So we're at 5 a.m. Monday. This is early Monday morning. Watch what happens. You've actually got a finger of precipitation working its way up the coast. Here's Patterson. All right? It could be raining Monday morning. Now that precipitation doesn't make too much northward progress. It's very light, and you now have a very, very strong storm with at least a 960 millibar central pressure. Remember I said 1013 is normal. 980 is a pretty strong storm. 960 is a very strong storm for central low pressure. We're now at Monday afternoon, 18Z, 2 p.m. Now here comes the next 24 critical hours. Watch where this storm heads, and know that this is from the 12Z model on the morning of the 25th. So this, as of this recording, is the latest model. It's making a left turn, and it's extremely tight. I don't even know what the central pressure is there. Maybe 958, I think I'm reading there. And it's working its way just abreast of the northern New Jersey, New York City border. And this is by Tuesday at 15Z, so Tuesday 10 a.m. And of course, tremendous amounts of rainfall. Now let's start thinking about the 540 line. You have it being pulled in, and it's as far south and east as western North Carolina. If it does make further eastward progress and gets pulled into western PA and New York, that's the area most likely to get heavy snow. The Adirondacks and the Catskills, like I said earlier, they're a little further east. May not happen. Again, you're going to have to be on the western periphery of this thing in order to get any snow out of it. So here we are, Tuesday evening, and it's got the storm right over I-95 on south central, southeastern Connecticut. Very windy, very rainy in New Jersey Tuesday night. Could be one of the stormiest nights you've ever experienced. Looks like the central pressure here is down under 952, and that would put it out Tuesday evening at 8 o'clock. Now it begins to weaken. Not quickly, but just a little. And it looks like, let's go back here to the maximum. If I have this, if this verifies, it's going to be right over, it looks like roughly JFK Airport, right over Brooklyn, which puts New Jersey just incredibly in very bad stormy conditions. So this could be a very big deal. It continues moving it north and westward, although weakening it slightly. It's still a very strong storm. It's up into New England now as we go forward into the future. It's weakening a bit, still moving northwestward. Not normal. It will eventually resume its eastward movement as it weakens. It's now down to a 992 or a little lower than that. And where are we now? We're at Friday morning, so like a week from tomorrow. And then it finally just falls apart and will begin to drift off to the north and east. You'll notice the cooler air does pull in behind it. We drop below the 540 line in New Jersey briefly, but again, there won't be enough moisture for any significant snowfall at all, if at all. Maybe a little bit here next weekend, it's possible, from this. And then things pull out, and it looks like another coastal storm develops, but a much more normal and weak one as it moves north and eastward. Anyway, this has been a full 30 minutes, so I'm going to stop here. I hope you got something out of it. I hope you find this interesting, and good luck to you. You're going to need it with the next few days in New Jersey.